Soil structure is the arrangement of particles and aggregates within the soil. It influences how the soil holds water, air, and nutrients. Soil fertility refers to the soil's ability to support plant growth and provide essential nutrients. One way soil structure affects soil fertility is by influencing water infiltration and drainage. A well-structured soil allows water to penetrate and reach plant roots, promoting healthy growth. In contrast, poor soil structure can lead to waterlogging or runoff, which can negatively impact plant health. Another way soil structure affects soil fertility is through nutrient availability. A well-structured soil promotes better nutrient retention and cation exchange capacity, making nutrients more accessible to plants. Additionally, soil structure affects root penetration and growth. A well-structured soil with loose and friable texture allows roots to grow deeply and access nutrients in the soil profile. Conversely, compacted or dense soils can restrict root growth, limiting nutrient uptake and overall plant health. The fourth way soil structure influences soil fertility is through the presence of soil organisms. Well-structured soils provide habitats for beneficial soil organisms like earthworms and microorganisms that contribute to soil fertility. These organisms help break down organic matter, release nutrients, and improve soil structure over time. Lastly, soil structure impacts soil aeration and gas exchange. A well-structured soil allows for proper air movement, preventing oxygen deficiency and promoting root respiration. On the other hand, compacted soils can limit air movement, leading to poor oxygen availability and reduced plant growth. In conclusion, soil structure plays a vital role in soil fertility by influencing water retention, nutrient availability, root growth, soil organisms, and aeration.